All right, so as we said, your header is solving inequalities, which sounds like a really tough word to write, but just sound it out. Right, so solving, we should know how to spell solving. I said that and then I tripped up. Solving, now inequalities, inequalities. INEQUALITIES. If you don't have 614 yet, raise your hand. I'll bring you one. Deliver with a smile.
It's the area code. What? 614.
Oh yeah. Today is Columbus lesson, I guess. 614. Anyone else need 614? Actually, ironically, pretty ironically, 614 used to encompass the Coshocton region a long time ago, and then they realized the population growth over here was going to be so big, they shrunk down the space that 614 covered because the people here was growing so rapidly. They're like, oh crap, we need 614 for Columbus, and they sectioned off other regions. So if you've never understood area codes before, it's just so your phone knows how to route your call. Right, so today, if you want, I guess I should cover this before we move on. If you want algebra tiles, grab those. But if you're going to get algebra tiles, also get an expression mat. And then last announcement where I'm going to need your help. I need to leave at 9:45. So right before our class ends. Now your next class is language arts, right? Because the schedule's back to normal. So you're just going to chill here till they're done. But I have to skedaddle to get off to my first appointment for today. So, if you've never heard skedaddle, it's a fun word. Also pronounced scudaddle by some people. But, skedaddle is more fun. All right, afternoon class, like PM 3B class. You are watching this video. You are taking notes as we go. When I say this is on your handout, it's on your handout also, which means you should be writing what we write on the smartboard. So please do that, because considering that I'm not here and Mrs. Goldring is probably going to be your sub, I'm gonna probably need to check your notes tomorrow. So when there's no guest teacher, she has to teach her class at the same time, and there's only one of her, right? So another teacher might come over and help, but Mrs. Goldring is probably just gonna take the whole afternoon block and kind of do it together. So we're gonna try to dive through this in about 30 minutes and give you guys a little bit of time for homework at the end. So if you could please work with me, that would be very appreciated. Now, who can remind us what an inequality is? Or if you can't remember that, what is an equality or an equation versus an inequality? Or what's in mean? Anybody have any information for me on this Monday morning? Bella? It's Tuesday. It means not, right? So inequalities, oh, so not equals. So instead, we're going to use that, or that, or that, or that, right? What's the difference in those symbols? There's two distinct differences. I can't talk about some answers. Eric?
Well, the one says they have a line underneath them and they're facing in opposite directions.
The very 7th grade. I love it though. Well, this one's facing the opposite direction as this one. And if I compare top to bottom, this set has these lines on the bottom versus these sets not. So let's write one of these down on our notes, wherever you want to put it. If it is this, go ahead and jot this down somewhere. Probably in your graph paper because you don't have tons of space on your white paper. That reads, I wish I had a little bit more space. I'm going to just do this. That reads x is, because we read left to right, which one's bigger here, the x or the 5? The x, because we're opening that way, so x is greater than, T-H-A-N, by the way, not E-N. Catching a couple people doing greater than, not than. It's greater than. Greater than. But then, this goofs with things. or equal to, right? So greater than or equal to, and then the number that we have, 5. So again, as a reminder, if we were to graph this, I'm trying to remind us of stuff that we did last week before we dive in. What number do I need to put on my number line?
5.
Just 5. That's it. Really, because we know everything up here is going to be bigger than 5. Everything down here is going to be lower. We never, ever make number lines different than that. Because I had somebody come to me and say, well, don't I have to put another number so you know that up here is the bigger numbers? No, because it always works like that. Now, if you want to, you can put like a 10 out here. I mean, it doesn't matter. But it always works. The bigger's on the right. So then we circle this. And then what's the next thing I have to ask myself? Nick?
If you know the number, like X, then you shade in a circle. If you don't.
Not if we know it. You're thinking of the right thing. We ask ourselves, do we shade? But Araya, how do we ask that question?
You have to figure out which side you're shading.
So, Araya is going to go which side first. So how do I know left versus right of the circle?
Depending on if it's greater than or less than, like, points to.
Yeah, if X is bigger, then we're talking about these values. But there's one more thing to think about that Nick alluded to about shading in the circle or not. Lily?
You have to shade in the circle because it's less than or equal to.
Yeah, again, this, the bar on the bottom, the or equal to, that tells us this gets shaded in. So that's going to be one of our big things today. Do we shade the boundary point or not? When we do, it's a potential answer. It works for this statement. If we don't shade the boundary point, this is called a boundary point, by the way, we'll use that word a lot today, it's not allowed to be a solution. Questions on this reminder from last week? The other trick, I don't like just teaching the trick though. The other trick is these take more ink to write the symbol. They take more ink to graph. Right? If your symbol takes more ink to write it, your graph will take more ink to draw it so you shade in the circle. That's just a little trick that for some people really works. So Jerry and Ken are working on this inequality, which is on your white paper. This is on your handout. It does not look the same because I cut most of the problem out. So they're working on that, but they need our help. So I'm going to skip down to some open page and write down what they're working on. 3x minus 1 is less than or equal to?
Yes.
What, 2x? So this you can do on your handout. It is the first thing on your handout. If I was you, I'd maybe write it down again, but you could also just work vertically from where it is. That's why I chopped everything else off. Now, Jerry and Ken need to figure out what x is allowed to be. Now, there's one problem on your homework. Actually, everybody look at, let me borrow this real quick. Look at 43 at the very bottom of this page. 43, Morgan, with me? What problem are we looking at? Yeah, because you're not. Look at the bottom of your practice page. I can tell when people aren't with me. It asks, of those numbers, which are solutions? So if Jerry and Ken were trying to test solutions, like if somebody said, hey, can x be 5? They could plug in a 5 and test it, right? But that's not the nicest method. So in 43, you're going to plug in the numbers and test it unless you do something else with it first. That's why we are going to do something else with it first. We want to put the x's together. Anyone have a suggestion for how I could put the x's together like we did last week with the algebra tiles? And if I were to make this to give you a reminder, think, Ramon. Take 60 seconds, and if you can, write down a thought or do something on your paper. Do something to show what you think we could do to try to get the x's together. 3x minus 1 is less than or equal to 2x. If you remember back to last week, we would show that work on both sides. We're going to do it together. Turn to a partner if you're not already talking to a partner. Turn to a partner and exchange your ideas. Come on, camera. (3x) and a negative 1 is less than or equal to 2x. I wish I could somehow random card through the YouTube video, but that wouldn't work very well. Because the afternoon class is going to just watch the video. Sarah, what could I do up here on both sides? Ooh, I could cancel 2 of the x's out on both sides because they're the same. So how we write that on our paper, what you're going to write down. Really? You're right, but first we show the work. Take away the 2 x's. We're going to show the work. This is why I said a highlighter might be useful. That leaves me with, I was about to write the wrong thing, just 1x and a negative 1, if I want to rewrite it, plus the negative. Less than or equal to them. Now my right side has nothing. Right? I took these 2 x's away from each of them. They're off my mat now. Did the same thing on both sides. How could I get rid of a negative 1? Because I can't, quote unquote, take it off right now. Because I don't have another negative 1 to take off over here. Somebody I haven't. Savannah? Ooh, I could take this away if I add. So I can just drop it down here and just say I have that now. What do I put on both sides? Or what do I put on the right side? Sorry. I put 0 on the right side. This is 0. Right? We added 0. Quote unquote. Now we can take away a negative 1. Now the other way to think about that, this is just a different way to think, is because in algebra we can do anything we want. Give me your eyes up on the screen real quick. This is what we have, right? 1x and negative 1, 0 over here. If I bring in a positive 1 on both sides, I did the same thing on both sides. Now these make 0 and they come out. It's the same exact thing as what Savannah just told me to do. I can either do that, bring in a 1 on both sides, and this will cancel, or we bring in 0 over here, cancel, same thing. It gets us the same result. So algebraically, though, what's easier to write, and when I say algebraically, that kind of defends we can do whatever we want, right? It's that branch of math. So what we do, quote unquote, what we write is that we're actually going to add 1 to cancel with the negative 1. And when we do that, it leaves us with 1x less than or equal to 1, which is what this shows. 1x is less than or equal to 1. Right? The algebra that we did just shows what we did on the expression map. So this becomes our answer. Try to graph it on your paper right now without my help. Take 30 seconds. Graph what that inequality tells us. Draw your line. Put your number on it.
I'm sorry for the interruption. Can I please see Joey Leach in the remote office for just a moment? Joey in the remote office. Thank you.
Yeah, wherever you can fit it. Graph. So don't move on to the next problem. That's a different problem. But using that blank space that you have, just draw a number line. Put your number on it. And graph what the results are allowed to be. So we should have number line. What number goes on it? 1. We then, I'm going to change colors for this just to make it look a little different. Do I fill in the boundary point? Yes, because we have the or equal. So we fill in the boundary point. And then if x is less or equal to 1. Well, now ignore the or equal. We took care of it. If x is less than 1, I go left, right? Less than is left. I go out there. Any questions? Oh, and for the afternoon class, that whisper didn't matter. This is everything we're doing today. Whisper for them too. All right, no questions? So now we get into working all three different types. So we can write it out in words, like B shows. We can write it out in symbols, like A shows, or we can graph it out on a number line, like C shows. For each of these, let's write or show the other two versions that are missing. So let's do A together, and then you can do B and C on your own. So A, it shows what they give us, that. Now we're going to read it to turn it into words. Right? When you read it, that turns it into our words for us. So, Zach, how does A read? How would you say that? Greater than? X is the bigger piece here? Remember, we open up towards the larger value. So this, make sure you're not reading anything over here. I'm going to cross that out for now. I'm going to cross this out for now. We're on A. If we open, it's less than. So we go to write this out. Please write this out. You should have a little bit of space on your paper somewhere. X is less, and guys, you have to have this is. That's very important. X is less than, and I'm just going to write the number to save some paper. -1.5. You could write out the words -1.5 if you want to write out the words. No, because this is just practice work we're doing together. But then if I go to show that on a number line, we don't need a big number line, right?
Doesn't it already have one?
No, A, B, and C are totally separate, guys. A, B, and so actually on your paper you could draw like vertical lines between A, B, and C because I put them beside each other.
Yeah, you do.
You don't need it very big. So -1.5. So Meredith, help me because you just volunteered.
Oh, thank you.
Is this circle on my number shaded or empty? Empty because this does not have the or equal. Our boundary point is unshaded. Then if x is less than the number, we go left. Right? Less is left. X is less than. Open boundary point, we shade to the left. I want you, and afternoon class, I want you on your own to try B and C. Write out the two missing pieces. So for B, you're going to write the symbols, X symbol number, and then a number line. For C, you're going to write out the verbal and the symbols. Or the words. I say verbal, but they say words. So for B and C, you are doing the other pieces that we're missing. These are on your paper, so you should not be mad that I'm moving things around. No. Nick has a good point. We do not, when I squiggly line, you don't really have to squiggly line. So, Nick, talk me through, what is B, what do I write here for the symbols?
X is.
Yeah, I like how Nick's like, well, I'm just going to read the sentence you're looking at, Mr. Hunt. Like, X is greater than 2. That's how you read the symbols, too. But Nick is showing me, I open towards the bigger, so X is greater than the number 2. Yeah. Ooh, or equal. You only showed me this.
No, he said it a little line.
This, right? We got to have the or equals. So X is greater than or equal to 2. So then, here's where Nick was asking me. So Nick, first off, do I shade or leave this circle open?
You do shade.
I shade. And then what he's asking me is, do I have to squiggly? No. So, do I shade to the right or to the left?
Right.
To the right. So especially on your paper, you could just like shade.
I like doing it from the
Yeah. So the squiggle is an easy way to say, you could, if you're trying to make the graph quick, you could just shade this and literally do that and you're done. Because that shows we're going that direction. Questions on B. This is our symbols. This is our graph. This is our words or verbal.
If we shade all the way up to the other arrow, do we have to draw another arrow?
No. Yeah, if you get to this, that kind of like takes the place of saying this keeps going. So you kind of just say they both keep going. Now, the only dangerous thing there, Lily, is there will be points in the future that we will get to a point where we stop and the region is like isolated. Like I want to buy between 10 and 12 like packages of cookies. Like I don't want to buy 40. So we would actually have a stopping point. So those are the only dangerous situations, but we're not there yet. Right now we're just continuously shading. So then in C, let's get some help from somebody here. Olivia, what do I write for my, let's do sentence first. What do I write for my words?
X is less than or equal to.
Notice Olivia just looked at the important number. That's got the point on it. It is shaded, so that's the or equal to.
It's just the opposite.
It goes to the left, so it's less than.
Isn't it just the opposite of B?
X is less than or equal to 2.
It would be two.
It's not, yeah, it's hard. You can't quite say it's just the opposite since they both involve the 2.
The different way.
Yeah. It's like if I want more than 2 pizzas or less than 2, but each of them has the or equal. So be careful, they each have the or equal. So this is like saying I want 2 or less. Hold up. Actually, give me your eyes up here, because this is interesting to talk about that I didn't plan out. This is saying I want 2 or more, right? Like if I'm ordering pizzas and they're going to give me more, sure, okay, I'll take more pizzas for free. But this is saying I want 2 or less. So if this might be like how much homework you want, right? I want 2 classes of homework today or less, right? You'd be okay if one class gave you homework, or if no classes gave you homework. But negatives don't really make sense. That gets into one of those other boundary points. I do actually have homework to give you guys back.
He also saw the free homework pass.
Mm-hmm. All right. So this is also on your white handout. I wanted to make sure we did a lot of these together today. So this is, I would underline boundary point because it's your vocab word. This is asking us, when is our boundary point part of what we want? When is it not? I want you to take at least 3 minutes, engage with this on your own. Try to decide, is the number they're referencing allowed to be part of my answer? Advice, either use a highlighter or your pencil to underline or denote something. Not only the number they talk about, but any other important words that will help us know what way do we shade, and do we shade the point or not? I don't want to highlight anything else until you guys have some time. Take at least 3 minutes. Afternoon class. That does not mean skip the video ahead a couple minutes. Stop what you're doing. Do this on your own. Let the video play natural speed. Sniffly nose like nobody's business. If you're breaking the speed limit, they can get you. I mean, that's the law is if you're over the speed limit. Now, most police officers won't waste their time to get you 4 miles over the speed limit, but they could. So think about when the speed limit's 25 in a neighborhood or 15 in like an apartment complex. If you're driving 25 in a 15-mile-an-hour area, that's a lot. Like 10 miles, that's a lot. You're speeding by a lot. But out on the highway, 75 versus 65 is not as big of a difference. So in that neighborhood, the cops will get you. Whereas out on the highway, they're like, they're kind of moving with traffic. But by law, if you're over the speed limit, you're over the speed. It's a limit, right?
Yeah, most people on the highway don't go to speed limits.
This one's always a point of conversation. A, because kids don't quite understand the law versus what their parents tell them. Pay attention that in B says what you can spend, what you're able to spend. Ooh, interesting. You'll see a problem like this next year. There's a maximum height on this roller coaster.
How do you know?
It's dangerous. Yeah, if you're too tall, it's dangerous. Or if the track space is really tight, because if you raise your hands, you might chop your hands off. Well, that's why they've done the math and they figure it all out.
Maybe they should test it. Don't worry, I'll never make it. Yeah, I'm
Do
never
we have
gonna
these on our paper? Or is this when I walk around and you're like, oh crap, he's walking around, I should actually do this?
What does the yellow traffic light mean?
A yellow traffic, they're all yellow.
No, like the
No, every traffic light is yellow.
like the light, not the green light with the red light.
Well, it means it's about to turn red.
No.
But what it really means is put your foot on the gas and get through the
Good.
light.
The yellow light means speed up.
Alright, so this is an interesting conversation. So Savannah, it's just your random card. Don't feel like I expected you to know all the driving laws. If the speed limit is 65 miles an hour, will I get a ticket at 65? No. Could I get a ticket at 66? 67? Yeah. Am I probably going to? Not probably. But if we go to graph what this actually represents, and X is a speed that could get a speeding ticket, I would put X is anything greater than 65, but not equal, right? Because I'm allowed to go 65. So we put our 65 on there. We leave the circle open and we shade anything to the right. Now, really, if you want to make your number line more accurate, in reality, 70, 75, something like that, 70-ish, is probably really where you're going to get a speeding ticket. But they could get you for anything. 66, they can pull you over. Now, the other thing is, they sometimes pull you over thinking like there's something else going on.
Yeah.
Right? So actually, if I was a police officer, I would have pulled somebody over last night for driving 13 miles an hour through my neighborhood. Because it looks suspicious of why they were driving so slow. Right? There's also minimum speed If you go under 45 miles an hour on the highway, you can get pulled over because it's dangerous. You're driving so slow, it's dangerous. Not just past you, somebody could come up without seeing you and hit you. Because if they're going 65, you're going 45, you catch up really fast. That difference in speed. Right. Especially if it's raining or something like that, or if you don't have your lights on, like all of this stuff is dangerous.
Question.
Yeah.
If you were getting pulled over for going 1 mile over the speed limit, how much would that ticket be?
Very low. It'd be like something silly. I think speeding tickets, well, it depends on what county, because all these things are like by the county. I've gotten a speeding ticket before, and it was within the 10 to 15 or 10 to 20 over range, whatever it is. They're like $70 to $100.
You went 20 miles.
No, there's ranges of what your ticket is. So there's like 0 to 10 or 15, depending on where you are. And then they bump you up to like the normal, what they pull people over and ticket them. And then there's a whole nother range of reckless endangerment that if you're driving super fast, they'll get you for reckless endangerment, which is you were going so fast, it's just reckless. Like literally, that's what they call it. All right, so Morgan, you are going to the mall. You have 10 smackaroos, another nickname for money. What can you spend? Ah, I love it. She says in between 10 and 0. So we're not just going to put one number up here. We're going to put 0 and 10. We're going to circle both of these. Can I spend $0? Yeah, I love it when I spend $0. I'm like, nothing I wanted to buy today. Can I spend $10? Yeah, I could spend all of it. Go home with no money, but an experience or something. And I could spend in between. We cannot spend less than 0 unless you get a job while you're there and somebody pays you. And we cannot spend more than 10. Then C, just like that situation. Oh, sorry, we don't know how to write this yet. This, write down on your paper a 0 and a 10 and put Y between them. Yeah, I'm serious. This is how we write this out. And that's why we're doing it together. 0 could be equal, so could 10. So put your or equal lines. Then, is 0 less than my shaded range? Or is it at the top of my shaded range? What's at the bottom, right? So 0 is lower than what Y could be. And 10 is on the higher side of what Y can be. So Y is in between 0 and 10, right? They could be equal on both of them. Here's the thing. These, give me your eyes, these inequality symbols, when used in a double, have to point the same way. They don't have to both be or equals, but they have to point the same direction. So when we come down here, we look at C. To ride your favorite roller coaster, let's write this out first. You must be at least 5 feet tall. Hold on, you must be at least 5 feet tall. Can I be 5 feet tall?
Yeah.
Yes. So X, 5 is less than or equal to X, right? X needs to be more than, you've got to be 5 or more. Sorry, not X, H. Well, we could use X, but they say H. But less than 7. Can I be 7? No. Less than 7. Please write this down, because you probably didn't, because you didn't know how. And that's okay, we're learning here.
Really?
I hope.
I mean, come on, man. Use common sense. This is a school. We don't learn.
So then 5 and 7 are both the points we care about. I circle both of them. I squiggly spaghetti between them. Does 5 get shaded?
No.
Yes, we can be 5. Does 7 get shaded? No, 7 is too tall.
Imagine being told that your shoes.
I have a friend who has been told that many times. Yeah. The Wolfgang family, shout out to Andrew and Daniel. They're crazy tall, and their older brother Peter, but they're all like 6'7" or taller. Like, so me, when Andrew stands beside me, like I feel like short. Like and Daniel has to duck under pretty much every doorway. Like these, obviously he'd be fine, but like any normal house, he just like, is
That's what
always
my
ducking.
uncle is.
Yeah.
Wait, my uncle's so So did he have to like find a house that?
Yeah, I don't know. Maybe it's just
Oh yeah,
tough.
My uncle
like.
All right, hold up. Hold up. I got one more, and then I gotta get out of here. Check out 38. You do not have that on your paper. This is where we're going to pick up tomorrow. So on your graph paper, afternoon class, listen. On your graph paper, this is the work that we should be able to pick up on tomorrow. Okay, Ellie's working on a dollhouse. We had a problem like this previously. One long board is 54 inches. Boom. She tells you that. But the short boards, you don't know. Use the rest of this information to write out some algebra. Try to play with this. Try to solve the situation. This is the last thing we're doing today. We'll pick it up tomorrow. Cool? All right, I got to stop the video. Afternoon class, I got to stop it, save it, and upload it so you have it. You guys are just going to hang out till language arts is done.
Bye, afternoon class.